GCSE Physics boosters, visible light. That's what this video is about. Now, there are three words which let's just check that you know what they mean. There's opaque, transparent, and translucent. Now, you will remember, hopefully, from an earlier video that when light falls on a surface, it's either reflected or it's absorbed or it's transmitted. Now, if a surface is opaque, then no light is transmitted. It is either reflected or absorbed. So we can't see Gordon the gnome behind this piece of paper or whatever it is. Transparent, all of the light is transmitted. So we can see Gordon. Hello, Gordon. Translucent, some of the light is transmitted. For example, a filter. We'll talk about filters later. They let red light through. So opaque, transparent, translucent. Now, smooth and rough surfaces reflect light in different ways. If you have a shiny surface, like a shiny metal or a mirror, now when rays of light hit a shiny surface, they all reflect back at the same angle, and that's why it's shiny, and that is called specular reflection. It's also why you can get an image from a mirror, a virtual image. So specular reflection is off a shiny surface. When rays of light hit a rough surface, for example, a piece of paper, now even though it's white and it's going to reflect just about all of the light coming off it, the rays of light are scattered. They go off in lots and lots of different directions. If you looked at the surface under a microscope, you'd see it was all knobbly and rough. And so the rays of light are going to be reflected in lots of different angles. And this is called diffuse reflection. So we have specular reflection and diffuse reflection. Remember these words. Let's talk about color now. Electromagnetic waves, we know there's a big spectrum. We know that a very, very small part of that is visible to us. But within that visible spectrum, from about 740 nanometers to 380 nanometers. Nano is times 10 to the minus 9, by the way. And that's the wavelength we're talking. We have all of these different colors. So each color is its own kind of group of wavelengths. So red is from about 740 to about 630, something like that. You would call it red. You would perceive that as being red. So each color has a narrow band of wavelengths, and so it has a narrow band of frequencies as well. Red has the biggest wavelengths and it has the smallest frequencies. Any wavelength bigger than red, you're going into infrared, which is invisible. Any wavelength which is smaller than violet, you're going into ultraviolet, which is invisible, at least to us. Now, opaque objects that appear a certain color, such as this banana. Now, this banana looks yellow, and the reason it looks yellow is because it's reflecting yellow. This banana is yellow because it reflects yellow light, and it is absorbing, now not Roy G. Biv, but R-O G. Biv, Rho G. Biv. Notice that the yellow's not there because it's reflecting it. This leaf is green because it's reflecting green light and it's absorbing Roy Biv. Yeah, these berries are violet because they reflect violet light and they absorb Roy G. B. Okay, so opaque objects absorb some colors and reflect some colors. This cat, Kevin the cat, is black because it's absorbing all of the colors. It's not reflecting anything. And this mouse, Michael the mouse, is white because it is reflecting all of the colors equally. It may actually be absorbing some, but what it reflects, it's reflecting equally. So we get Roy G. Biv and it appears white. Filters. Let's talk about filters. Now, a colour filter will absorb some colours and transmit others. For example, a blue filter transmits blue. It lets blue get through and it will absorb everything else. A red filter will transmit red and it will absorb everything else. This can be a little confusing. Students think that, oh, it's a red filter, so it stops red. No, it isn't. It's a red filter, so it lets red get through and it stops everything else. Okay, a red filter transmits red. Here's a question. Have a think about this. Imagine you're in a very, very dark room, but you've got a torch which has got a red filter on it. Maybe you've just been doing some astronomy. And anyway, this torch shines red light. Now, what colour would a blue sock appear to be in red light? If you shone your torch on a blue sock, then the blue sock would appear to be, have a little think, and I'll show you the answer. It will appear to be black. It would appear black. Now, why? Because a blue sock absorbs red, so it won't be reflecting anything. And if it's not reflecting anything, it's going to appear black. Now, if you thought that was easy, then these three will be dead easy. A red sock in blue light, a red sock in red light, and a white sock in red light. Have a little think, and the answers are obviously